See, what happens is when we are tapping this key, current will start flowing. That is, there is a changing magnetic field. Changing magnetic field induces the current in the second coil. Changing magnetic field induces the current in the same coil, but in the opposite direction. So this is known as self-inductance. Okay, this is known as self-inductance. So we have two types of inductance. One is what? Mutual inductance, self-inductance. Mutual inductance means, suppose this is the first coil, this is the second coil. We are changing when we use the tapping key, current is flowing in opposite direction. When current is flowing in one direction, it will give north pole, the other direction south pole. So by changing the magnetic field, by changing the direction of current, we are changing the magnetic field, direction of the magnetic field. Because of that, current is induced in the second coil. This phenomena is known as mutual inductance. In self-inductance, what will happen? The same coil is there. There is only one coil and there is a tapping key. Then what happens when we tap the key? What happens? There is a changing magnetic field. Because of that, current is induced in the same coil but in the opposite direction. This phenomena is known as self-inductance. Okay. Now we are going to study about the the formula. What is that? We got here n into phi b. What is phi b? Is directly proportional to the I. Phi b, that is magnetic flux is proportional to the current. So the formula is what? N into phi by n into phi b is equal to L into I, where L is said to be the inductance. L is said to be inductance. It is measured in what? It is measured in Henry. It is measured in Henry or microhenry, millihenry, and all. So these are the units. And it's a scalar quantity, and the formula is what? The dimensional formula is ml square t to the power of minus 2 a to the power of minus 2. This is the formula for inductance. Okay. So what is inductor? Inductor means a choke. The choke which is in the tube light. Okay. If you see the tube light, this is the tube light. Now here you can see one thing. This is said to be choke. Okay, the choke, this is the starter. Nowadays in LED tube lights, you won't see this one. This choke is nothing but an inductor only. Choke is an AC inductor. We have two types of inductors, DC inductor and AC inductor. So, sir, 3 o'clock, sir, class. Class is 3 o'clock. Muhammad. Okay. Now, so here we have the choke. The choke is also known as an inductor. Is that clear? Is it
yes,
clear?
sir.
Okay. So now next one here, we'll remove this one. We'll directly go to the set. This we will discuss about mutual inductance. Okay. Now here mutual inductance. So mutual inductance. Now, so there are two coils. They are coaxially mounted. These two coils are coaxially mounted, and L is what? L is the length of the coil. L is the length of the coil. R2 is the radius of the bigger one, and R1 is the radius of the smaller one. Now S1 is the first coil, and N1 is the number of turns. Similarly here, S2 is the second coil. Oh, okay. Yeah, if you can get, I'll give the mic. So here we have small one is the radius of this is R1, the coil is S1, and N1 is the number of turns. So the bigger coil is R2, S2 is the coil name S2, and N2 is the number of turns. Now, so N1 is, I'll write it here. Okay, two long coaxially solenoids. So there are two long coaxial solenoids. Coaxial solenoids of length L. Okay, of length, whose length is L. Okay, whose length is L. Now, N1 is what? N1, capital N1 is total number of turns S1. Total number of turns S1, and N2 is what? Total number of turns S2. Okay. Now, so when you set up a current in S2. Suppose set up, now first what happens, set up current in S2, which is current in set up current I2 in S2. When you set up the current, what will happen? Then magnetic flux through S1. So what will happen when you, this is S2, the bigger coil. The big coil is there. In the big one, we pass the current. When we pass the current, there is a magnetic field around it. So the second one will fall in the second coil, the small one, S1, will fall in the magnetic flux of S2. Once again, we are allowing the current to flow through S2, a changing current. When we allow the current to flow through S2, around it there is a magnetic field. Means what? The small coil will fall in the magnetic field of this big coil. Is that clear? The small coil will fall in the magnetic field of the big coil. Now, so magnetic flux through S1. So magnetic flux, there is a magnetic flux. Okay, magnetic flux through S1 is what? Is phi1. Magnetic flux through S1 is phi1. So flux linkage with solenoid S1. So flux linkage. What is a flux linkage now? The flux linkage. 1 second. Hold on, okay? I don't know because it's coming. No. Flux linkage with solenoid S1. With S1 is what? Is N1 phi1 is equal to N1 phi1 is equal to M12 into I2. M12 into I2. See here it was N1 is the number of turns, phi1 is the flux given by the big coil, the big one is phi1. And now M12 is the mutual inductance and I2 is the current in the second one. Is that clear? We give the current in the second one, right? So I write I2 here. Where is that? Yeah, I2 is here. That's right. I2 in S1, S2. Is it clear, all of you?
Yes, sir.
Okay.
Thank you. No difference.
Now,
Yeah.
now equation number 1. Okay, this is equation number 1. Now, here M12 is said to be mutual inductance of S1. M12 is mutual inductance of S1 with respect to S. Mutual inductance of S1 okay, with respect to S2. Now M12 is also known as coefficient of mutual M12 is also known as coefficient of mutual inductance. Okay, M12 is said to be the coefficient of mutual inductance. Okay. So now what happens here? The second one, magnetic field due to a solenoid is given by what? Magnetic field given by a solenoid. Is what? B is equal to mu 0 Ni. This is the formula. Okay. Mu 0 Ni. Ni is a number of turns per unit length. Okay. Mu 0 Ni. That is what? Mu 0 Ni is mu 0 Ni is the formula for magnetic field around a solenoid. Okay. So we can write here. So for the second coil, this is mu 0 N2 I2. Okay. Mu 0 N2. So magnetic field due to current. So magnetic field due to I2 in S2 is given by mu 0 N2 into I2. Okay, mu 0 N2 into I2. Now resulting flux is how much now? the resulting flux is given by, just substitute N1 is equal to what? N1 is equal to M1 to I2. What is N1? Number of turns per unit length. N1 is equal to N is number of turns per unit length. So what happens? N is equal to small n into L. So this is the formula. So we are going to write N1 L1 into 5. Flux is what? Flux is B dot A. B dot A. So B into, what is B? See, I'll just write first the formula. What is that? N is what? N into L. N1 L1 into what? B dot A. So what is B? N1 L1 into what is B? B is mu 0 N2 I2 into area. Area is pi r square. Pi r square. Pi r2 r2. Okay, pi r1. N1 phi1 is equal to, if it is N1 phi1, it will be N1 N2 L2 into I2. So this is the formula. Okay, this is the total value. Now simplify it. N1 L1, sorry, N1 N2 L1. Okay, mu 0 also here. Mu 0 N1 N2 L1 into pi r1 square I2. Pi r1 square into I2. This is the formula which is given. Clear with you? See once again. Listen.
Sir, parallel discussion with drawing, sir.
When it is 8th, no? 8th of Feb.
Yeah.
Time is there. No?
नहीं सर सबने कर लिया शॉपिंग
सर अब बॉयज को देखो यार कुछ भी नहीं कर कच्चा बन गया है
नहीं उसका वो
Mohammed. He is in the meeting. No. No, here we have. See, once again, listen. There are two coils, big one and small one inside the other. They are coaxially mounted. Now, our concept is mutual inductance. Means by changing the current in bigger coil, I want to induce current in the smaller one. That's my intention or the aim of the experiment. We can think. L is the total. What is the solenoid? A long helical wire in the form a long helical wire, which is long helical wire, which is whose length is much greater than the radius. Whose length is much greater than the radius, and they are very closely packed and enameled. Okay, so that that is known as the solenoid. Now here, L is the length of the solenoid, S2 is the bigger one, and R2 is the radius of the bigger one, and N2 is the number of turns of the bigger one, bigger coil or bigger solenoid. The smaller solenoid is R1 is the radius, S1 is the name of that, and N1 is the number of turns. Longs of two, we are taking two long coaxially solenoids, so whose length is L. N1 is a total, N1 is total number of turns, which is S1 of S1, and N2 is total number of turns S2. So set up, and now what we have to do is we have to set up current I2 in S2. The bigger one we are going to set up the current. So what happens around it? There is a magnetic field. So what happens around when there is a magnetic field? What will happen? This the smaller coil will fall in the magnetic field of the second one. Understood? The smaller one, okay, the smaller one falls in the smaller coil will fall in the magnetic flux of the bigger one. Okay, is it not? Yes.
Yes, sir.
Yes, Aaron. Okay. So what happens if suppose madam will wear nice perfume, then you will fall in the aroma of.
Sir, not her, sir.
Okay. So N1 is the total number of turns. So N1 is the total number of turns. Is it not? And N2 is the total number of turns in S2. So set up current in I2, then there is a magnetic flux. Okay. So flux linkage with S1 is N1 phi1 is M1 to I2. So M12 is the I told once. Okay, recently I told one of the she's wearing. I never appreciate. Okay, I never have that tendency. So recently I told one teacher like she's wearing a very good perfume. She was so happy. So don't ask him who is that.
No, that's
It's recorded later on. Okay, so M12 is what magnetic inductance of S1 with respect to X2. Okay. So she started explaining her perfume, which company it is and all. So I was listening to her. So M12 is what coefficient of mutual inductance. So magnetic flux given by solenoid is mu 0 Ni. Magnetic flux due to I2 in S2 is given by mu 0 N2 I2. And the resulting flux is what N151. Just multiply it, we'll get the answer. Please do it. Come on. Is it clear, all of you?
Yes, sir.
Okay. So current I1 through S1 and flux linkage with S2 is given by, and flux linkage with S2 is given by what? N252 is equal to N252 is equal to M12 into I2. This is equation number 4. Equation number 3 and equation number 4. So what happens now? M21 is mutual inductance of M12 is mutual inductance of S2 with respect to S1. S2 with respect to S1. M12 is mutual inductance of S2 with respect to S1. So N252 is equal to what? Here we have N2 into 52 is equal to what? N2L2 into L into pi is what? B dot A. So we can write here N2L into mu 0 and Ni into pi R1 square. Okay. Pi mu 0 N1 I1 into pi R1 square. Pi R1 square. This is the second formula. Now we are going to equate both of them. What is that now? So here what will happen now? N2 mu 0 N1 and L into pi R1 square into I. Okay. So this is equal to what? M21. Okay, M12 is finished. M21 into I1. So M21 is equal to what? Mu 0 N1 N2 into L into pi R1 square. Okay. This is the answer. Okay. So this completes your answer. Just copy this one. So instead of writing M12, here we are writing here M12 equal to M21, which is equal to what? M. M is the mutual inductance term. M is nothing but mutual inductance term. So therefore N151 is equal to Mi2. Okay. So here N151 equal to Mi2. Okay, this is the formula. Okay. So we also have the formula. What is that? According to the Faraday's electromagnetic induction, E is equal to minus N into d phi v by dt. d phi v by dt. The same thing can be written as E is equal to minus M into di by dt. Minus M into di2 by dt. So here we have N151. So this is the formula. So we induced current is given by that formula. Okay. Please copy this. As I told you, in self-inductance, what happens? We are inducing current by changing the current in the same coil. When we are changing the current in one, the current is passing through the coil, and see, this is the current, this is the coil, and we have connected to the battery, and then this is a tapping key. Now, when we are tapping this key like a bell switch, then what happens? The current is already flowing, but when you are tapping it, there is a magnetic field will go forward and backward. Because of that, current will be induced in this opposite direction. This is also known as back EMF. This concept is also known as back EMF. This concept of back EMF is especially used in big engines, turbo engines like aeroplane engines, ship engines, and all. They use this concept, okay, in fighter planes and all. They use this particular concept for the motors, okay. So now here we have N5B. N5B is proportional to I. So we write N into 5B is equal to what? Equal to L into I. Where L is said to be self-inductance. Okay. L is said to be self-inductance. Now, if suppose A is the area of cross section. A is the area of cross section, and L is the length of the coil. Okay. And N is small n is number of turns per unit length. Number of turns per unit length. Number of turns per unit length. So what happens here? We have the formula small n is equal to capital N by L. Number of turns. So here what happens? Capital N is equal to small n into L. Okay, this is number of turns per unit length. So what will happen here? V is equal to what? V is equal to mu 0 Ni. The formula for V is equal to mu 0 Ni. So we write N into 5V is equal to what? N into L into 5V is equal to what? V into A. So mu 0 Ni is the formula. Area is again pi r square. Okay, I'm just writing capital A. So the formula is mu 0 N square A L I. All are constants except the current. Mu 0 is constant, N is constant, A is constant, L is constant. All are constants. Only I is variable. Okay. So number of what is small n? Small n, keep that in the mind. Number of turns per unit length. So we can write capital N is equal to small n into L. This is the important thing which we are going to substitute over there. Now here what happens? We have the formula here. L is equal to what? L is equal to, I'm taking N into 5V divided by I. So that is equal to what? L is equal to L is equal to what? L is equal to mu 0 N square A L I divided by I. This and this will go away. L is equal to what? Mu 0 N square A into L. Okay, this is the value. And what is L? L is equal to, we can write mu R into mu 0 N square A into L. This is the value. Okay. Mu R is said to be relative permittivity. Mu R is said to be relative permittivity. Relative permittivity. Mu R is said to be relative permittivity. Clear? Now, if you want to write the work done, dw by dt is equal to, we write here, dw by dt is equal to E into Y. Okay, we know that V is equal to W by Q. Okay, W is equal to VQ. So when I'm changing, see here, when I'm changing dw by dt, it will become V into dq by dt. But what is dq by dt? It is I. dq by dt is I. So I'm writing EI. Is that clear? See, V is equal to W by Q, W is equal to VQ. This is important. So when you change this one, this also will change. So dq by dt is current. Okay, dq by dt is current. So now what we are going to do, dw by dt is equal to what? It is equal to E is equal to Li. E into I is what? Li into di by dt. This value is equal to Li into di by dt. Li into di by dt. So the work done is equal to what? W is equal to integration of dw, which is equal to 0 to I Li into dt. Okay, Li into dt. This is the formula. So we can write W is equal to what? Half Li square. When you integrate it, it becomes half Li square. This is the energy stored in an inductor. Like capacitor, energy stored in capacitor is half CV square. Similarly, energy stored in the inductor is half Li square. Okay. So that's it. So this completes your self-inductance. Okay. So we'll stop here for today. Tomorrow, same time. Same time I will take, but I will be starting alternating current tomorrow. AC current.
Okay, sir.
Please join on time, everyone. Okay. Because
Sir, tomorrow we have practical exam.
What you have? You have multimedia exam.
No, sir, physics.
No, I didn't get you. Can you say it again, please?
Sir, we have tomorrow physics board practical exam.
Board practical exam. Tomorrow is Sunday, right?
Yes, sir, tomorrow we have.
Why they are torturing children like this? Okay then. Okay, carry on. We'll see tomorrow then.